Right, hello again. So this is another C2 paper, May 2011 this time. Okay, so first question is another like a bog standard integration. The only kind of difference here is we've got limits on our integral. So first thing we need to do is integrate the expression. So we'll have 2x to the 4 over 4, so I'm adding 1 to the power and then dividing by the new power, plus so the 3 is just going to become 3x. And then we would have a plus c, but because we're doing definite integration, we don't need that. And then you could tidy that up if you want and make it x to the 4 over 2 plus 3x between 5 and 2. So then we need to sub in 5 to this and then take away what we get when we sub in 2. So we're going to be doing 5 to the 4 over 2 plus 3 times 5 and take away 2 to the 4 over 2 plus 3 times 2. So that gives me 5 to the 4 over 2 plus 3 times 5 is 327.5 minus, and then 2 to the 4 over 2 is going to be the same as 2 cubed, plus 3 times 2 is 14. So that gives us 313.5. Right, so you get a mark for this unsimplified, a mark for, so this basically means subbing in 5 to this and taking away what you get when you sub in 2, and then final mark for 313.5. Right, question 2, a sequence is defined by, so this u1, so it means the first term is 10, and then this ur plus 1, so in other words, to get to the next term, we do 5 divided by our current term squared. So if we're finding u2, we're going to have to take 10, in other words u1, and sub it into that. So we're doing 5 over 10 squared, which is 1/20th or 0.05. And then this is what's called an iterative formula, and then we can keep subbing in these numbers to give us the next term. So now we're doing 5 divided by the last term squared. So I'm going to put in my calculator, 5 divided by answer squared, and that gives me 2000. So u4, which is the last one they want, so that's 5 over 2000 squared. Now because I put 5 over answer squared in my calculator, I can just press equals again, and I get 1 over 800,000, which is 0.0000125. So if we write down a few more terms, if I press equals again, we get, so u5 is going to be some really big number with loads and loads of zeros, and then after that the next number's got 25 zeros and then the number. So you can see it's kind of alternating from being a kind of big number to a small number, and more so. So we've got 0.05, then 2000, then an even smaller number, then an even bigger number, then an even smaller number. So it kind of seems like it's oscillating, but remember an oscillating sequence has to be oscillating around a certain point. For example, 1 minus 1, 1 minus 1 is oscillating around 0, whereas this is jumping all over the place. So when it says what happens to the terms of the sequences r tends to infinity, well, they're just diverging. So we could go more into it and say, well, the even terms are getting closer and closer to 0, and the odd terms are getting closer and closer to infinity. But really all we need to say is that the terms are diverging. So you get 2 marks for finding all the terms, so these, and you could have written them as fractions if you want, and 1 mark for saying divergent. It says do not allow oscillating or getting bigger and smaller or getting further apart. So you can allow alternate terms tend to 0 and to infinity. Okay, question 3. The equation of a curve is y equals square root of 1 plus 2x. Calculate the gradient of the chord joining the points on the curve where x equals 4 and x equals 4.1. So if we imagine our curve, here's where x equals 4, and here's where x equals 4.1, and they're asking us to find the gradient between these 2 points. So if we're finding the gradient, the first thing we need is the y values. So this is going to, if our x value is 4, our y value is going to be 1 plus 2 times 4, which is a square root of 9, which is 3. Now if we put in 4.1, we're going to be doing 1 plus 2 times 4.1 and square rooting it. So it's going to be the square root of 9.2. And let's leave it like that because that's a nice exact number. So then if we find our gradient, we'll be doing square root of 9.2 minus 3, so that's the change in y, and the change in x is that 0.1. So square root of 9.2 minus 3 over 0.1 is 0.3315. Right, showing the points you use, calculate the gradient of another chord of the curve, which is a closer approximation to the gradient of the curve when x equals 4. So you can see this chord here, what they're trying to do is approximate the actual gradient we get there. So if we pick a point which is even closer, so let's say we pick a point like where x is 4.01, you could pick any point between 4 and 4.1, but 4.01 seems a natural one to go for. So now the y coordinate will be the square root of 9.02, I want to say. I'm just going to double check that. 1 plus 2 times 4.01. Oh, whoops, I meant 4. Yeah, so again, we can work out the gradient again, doing square root of 9.02 minus 3, and now it's over 4.01 minus 4. And that will give you 0.3331, and both of these are to 4 significant figures. Okay. Right, good. So you get a mark for selecting a value anywhere between 4 and 4.1, or of two values between 3.9 and 4.1, centered on 4, and answer's got to be closer to a third than 0.3315, which ours was. So that was the answer for that one. Okay. Oh, they said 4 decimal places, didn't they? Anyway. Right, the graph of y equals ab to the x passes through the points 1, 6 and 2, 3.6. Find the values of a and b. Right, so I think here what we should do is sub in both of these points, and then we're going to get two simultaneous equations. So if we sub in 1, 6, we'll have 6 equals ab to the power of 1, which we can just forget about, and 3.6 equals ab squared. Okay. This kind of does look like it could be a log graph question. You could actually do it like that by logging this, but I think kind of doing it like this and then doing simultaneous equations is just as easy. So what I think we should do now, let's call this equation A and this equation B. Let's do equation B divided by equation A, because what that will do will eliminate the A's in the equations. So on the left hand side we'll have 3.6 over 6, and on the right we'll have ab squared over ab. So the a's cancel, and then this b squared over b will just equal b. So we've just got to do 3.6 divided by 6, which is 0.6, and then we can sub that into either of the equations to work out a. So we know 6 equals ab, so now 6 will equal 0.6 a. So 6 divided by 0.6 is 10. So we get a equals 10. Okay, so you get one method mark for that and then two answer marks for 10 and 0.6. So you can see there they've showed you could do it by using logarithms, and that would get you to the answers as well. Right, find the equation of the normal to the curve y equals 8x to the 4 plus 4 at the point where x equals a half. Right, so if we want to find the equation of the normal on our curves, let's imagine it's at some point here where x is a half. Well, first thing we're going to have to know is the gradient, and then we can work out, well, what's the gradient of the thing 90 degrees to it. So to do that we're going to have to differentiate. So we'll have 4 times 8, which is 32x cubed, and then the 4 disappears. So if we sub in the x coordinate, which is a half, so we'll be doing 32 times a half cubed. That gives us 4. So we know the gradient is 4, so the gradient of our normal must be minus a quarter. So we've got to flip it and change the sign. Okay, we also need to know a point on the curve, so we're going to have to sub this x value in to find the y value. So I'm going to sub it into the top equation. So 8 times a half to the 4 plus 4 is 9 over 2, or 4.5. So the equation of the normal, we can do y minus y1 equals x minus x1. So we'll have y minus 9 over 2 equals minus a quarter x minus a half. And then there's nowhere that says we need to put it in a certain form, so I think we can leave it like this. Let's see what they think. Yeah, so they've left it like that there. So you get a mark for differentiating, a mark for subbing in a half, a mark for doing minus 1 over your gradient, a mark for getting the y coordinate, and a final mark for that. And if you rearrange it all, you might have got that. But really, all you're doing is just giving yourself more opportunities to make errors if you're rearranging it. Right, 6. The gradient of the curve is given by this. Given that the curve also passes through the point 94, find the equation of the curve. Right, so this is nothing to do with tangents or normals now. So we've got the derivative and we want to find the original equation. So we're going to have to integrate the derivative. So 6 root x is the same as 6x to the half minus 2. We want to integrate it. So that's going to give us 6x to the 3 over 2 divided by 3 over 2 minus 2x, and then don't forget your plus c. And that's going to be the equation of our curve, but we can tidy it up, and also we can't leave this plus c here. So 6 divided by 3 over 2 is 4x to the 3 over 2 minus 2x plus c. And then to find c, we're going to have to substitute in our 0.94. So the y value is 4, and it'll be 4 times 9 to the 3 over 2 minus 2 times 9 plus c. So that right hand side, 4 times 9 to the 3 over 2 minus 18 is 90. So we get 4 is 90 plus c. So c will be minus 86. And then just don't forget to write out the full equation at the end. So y equals 4x to the 3 over 2 minus 2x minus 86. So that's our full answer. So 2 marks for integrating. Actually 3 marks for integrating if you get that 4 at the end. And then correct substitution gets you another mark, and then your final answer mark for that. Right, solve the equation tan theta equals 2 sine theta. So with all of these, I'd recommend kind of replacing tans with sine over cos to start. And then let's try and get everything on one line. So we've got sine theta equals 2 sine theta cos theta. Okay, now don't be tempted to divide by sine, because you're actually going to lose solutions there. Like for example, if I had x squared equals 9x, and I might think, oh, let's divide by x, and that just gives me x equals 9. But actually what we should do is put everything on one side and factorise. So we can factorise out an x here, and we can actually see, well, x can equal 9, but it could also equal 0. So just be aware of that when you're doing trig. So here we shouldn't divide by sine, but we can do the next best thing, which is bring it over to this side and then factorise it. So we can take out sine theta, and we'll have 2 cos theta minus 1. And now it splits into 2 equations, just like it does when you factorise a quadratic. So we want sine theta to equal 0, and I think we can solve that. And we want 2 cos theta minus 1 to equal 0, which if we rearrange gives cos theta is a half. So let's do the sine theta one first, and we're solving it between 0 and 360. So sine theta looks like that. So I think without a calculator, we can see that that's going to equal 0. At 0, 180, and 360. So there we've already got 3 values for that. And then cos theta equals a half. So cos looks like this. There's 90 and there's 270. So I'm going to do inverse cos of a half, and that gives me 60 degrees, which is about here. And then we can see we've gone in 60 from here, so we can use the symmetry of it to think, well, we've got to come in 60 from 360. So 360 minus 60 is 300 degrees. So you see we actually get 5 answers in total. Okay. So you get 1 mark for that. 1 mark for getting to 2 cos theta minus 1 equals 0 and sin theta equals a half. 1 mark for 0, 180 and 360. And another final mark for 60 and 300. Yeah, okay. Right, using logarithms, rearrange p equals st to the n to make n the subject. So I think what we should do to start is just log everything, if that's what they're telling us to do. So log p equals log st to the n. So now we can kind of break apart this right hand side using rules of logarithms. So we'll have log s plus log t to the n. So then we'll have log s plus n log t. And then I think we can just move stuff around and make n the subject. So if we take away log s, oops, and then divide by log t. So we'll have log p minus log s, which I guess you could write as log p over s if you wanted, over log t. So something like that. Yep, so either of these are fine. So 1 for kind of doing that first step of breaking it apart, 1 for that next step, and 1 for then the rearranging. And just be aware that if you do use that log p over s, you can't do anything when you divide by log t, so you can't make that log p over st or anything like that. Right, 9. You are given that, so another log question. Log base a, so we don't know what this base is, x equals a half log 16 plus log 75 minus 2 log 5. Right, so I think what we need to do here is try and turn all of this expression on the right hand side into one logarithm, and then we know if that's like log 7 or whatever, then x must be 7. So let's see what we can do with this right hand side. So we're kind of doing the opposite of what we're doing on question 8, because here we're having to kind of compact the logs rather than break them apart. So I'm going to make that log of 16 to the half. I know I haven't put any a's here. I probably would in the exam, but it sounds like a lot of work. And then minus log of 5 squared. Right, so log 16 to the half is log 4, because that's just square root of 16. Can't do anything with log 75, and that's minus log 25. So now we can just use log rules to put these together. So we can do 4 times 75 divided by 25. So log 75 minus log 25 will be log 3, and then log 4 plus log 3 will be log 12. So if log ax equals log a12, well, x must be 12. So there you get a mark for 16 to the half and 5 squared, either of those seen or implied, a mark for kind of putting them together at all, and then a final mark for 12. Right, question n. The nth term of a sequence Tn is given by Tn equals sine theta plus 180 n degrees. Express T1 and T2 in terms of sine theta. Okay, so T1, if we make so n equal 1, we'll have sine of theta plus 1 lot of 180. Alright, so but we need that in terms of just sine theta, so we can't have sine theta plus 180s there. So let's think about what that looks like. So there's sine theta. Now sine theta plus 180, we'll shift that to the left by 180 degrees. So in other words, it will look something like this. So remember, it goes on forever, it's kind of shifted it along. So another way we could think of that is it's a reflection in the x-axis, which if we think of this as f of x, this would be minus f of x. So sine theta plus 180 is the same as minus sine theta. So if we do t2 now it's going to be sine of theta plus 180 times 2, which is 360. So if you think what's happening here, it's been moved along 360 degrees, so it would actually be just the same as sine theta at the very start. So this would just be sine theta. Okay, so pretty simple mark scheme, one for minus sine theta, one for sine theta. Right, so on to section B now. The standard formulae for volume V and total surface area A of a solid cylinder of radius r and height r. V equals pi r squared h and A equals 2 pi r squared plus 2 pi r h. Use these to show that for a volume with A equals 200, so we know this equals 200, that V equals 100r minus pi r cubed. So there, they've got a formula for V, but there's no A's in it, there's no H's in it, there's just R's. Okay, so I think what we need to do is try and make h the subject of this and sub it into here. So let's have a look at that. So 2 pi r squared plus 2 pi r h equals 200. So let's divide by 2 to start. So we've got pi r squared plus pi r h equals 100. So if we want to make h the subject, by the way, there's loads of ways of doing this. This might not be the most efficient. We'll have pi r h equals 100 minus pi r squared, and then I'm going to divide by pi r. So I'd have h equals 100 minus pi r squared over pi r. And now I've got h as the subject, I can sub it into v equals pi r squared h. So we'll have v equals pi r squared, and then we've got 100 minus pi r squared over pi r. So we can cancel out a pi and one of the r's, and then all we have to do is times the top of this fraction by r, so we'll have 100r minus pi r cubed, which hopefully is what they've got. Yeah, good. Right, find dv by dr and the second derivative d squared v by dr squared. So dv by dr is 100 minus 3 pi r squared, and then if we differentiate that again, so remember, treat the pi just like any other number, which is all it is, it's just some random number, and then differentiating again, the 100 disappears and we'll have minus 6 pi r. Okay, part 3, use calculus to find the value of r that gives a maximum value of v for v, and hence find this maximum value. Right, so we're going to have to set the first derivative to 0 and then solve it. So what I would do here is, so we know 3 pi r squared will equal 100, so r squared will be 100 over 3 pi. So r will be plus or minus the square root of that. Now, because because the radius is a positive thing, we can just ignore the negative square root. In the exam, I'd probably recommend just writing a little note of that. So that gives you 3.257 to 4 significant figures, but I'm going to keep the exact value in my calculator. So, and then to show it to maximum value, we might want to sub it into here. So if we did minus 6 pi r, because r is positive, or you could even work out the exact value, that has to be not greater than 0, less than 0, because it's minus 3 positive things times together. So therefore it is a maximum. But they actually want the maximum value for v. So we're going to have to take that number and sub it into this formula. So I'm going to put my calculator 100 answer minus pi times answer cubed. So I get 217, let's just say 0.16. And they've given us no units, so we can just leave it without units. Right. So, a mark for, so they've done very similar to us. They've made H the subject, a mark for subbing it into V, and a mark for that correctly obtained. And then 2 marks for dV by dr and 1 mark for second derivative. 1 mark for setting your first derivative to 0, 1 mark for getting to 3.26, and a final mark for 217. Deduct 1 mark only if this part, yeah, so that's fine. We maybe went a bit over the top with our significant figures. Right, question 12. Jim and Mary are each planning monthly repayments of money they want to borrow. Jim's first payment is £500 and then he plans to pay £10 less each month, so that his second payment is £490, his third is £480, and so on. Calculate his 12th payment. Right, so this is a arithmetic sequence because it's going down by the same amount each time. So A is 500 and then the difference is minus 10 because it's going down by 10 each time. So 12th term will be A plus 12 minus 1, lots of D, so plus 11D. So 500 plus 11 times minus 10, which is £390. Right, he plans to make 24 payments altogether. Show that he pays £9,240 in total. Right, so so now we're working out S24, so we want the sum of 24 terms. So that's going to be n over 2, 2a plus n minus 1d. This is all in the first page of your formula book as well. So 24 over 2 is 12. 2a is going to be 500 times 2 plus n minus 1d, so 23 times by minus 10. So we're doing 12 times 1,000 plus 23 times minus 10, which is 9,240. Okay, good. Right, Mary's first payment is £460 and she plans to pay 2% less each month than the previous month. So she's got now a geometric progression. Calculate her 12th payment. So here, her A is 460 and then R, the common ratio, we've got to think what takes off 2% each month. So that would be 0.98. So her 12th payment, so U12 is going to be AR to the 11. Again, all these formulae are in your book, so UN is AR to the n minus 1, so U12 is AR to the 11. So this is going to be 460 times by 0.98 to the 11, which is £368.34. Show that Jim's 20th payment is less than Mary's 20th payment, but his 19th is not less than her 19th. Right, so let's work out Jim's 19th and his 20. So that's going to be 500 plus 18 times minus 10, and then his 20th is going to be 500 plus 19 times minus 10. So 500 times, plus 18 times minus 10 is £320, and the next one, well, because it goes down by £10 each time, is going to be £310. So for Mary, her 19th term is going to be 460 times by 0.98 to the 18. 460 times 0.98 to the 18, which is £319.76. So we can see Jim's 19th payment is higher than her 19th. And her 20th is going to be 460 times 0.98 to the 19, which is £313.37, pence, which then goes above Jim's. Right, not last part. Mary plans to make 24 payments altogether. Calculate the amount she pays in total. So now we're working out S24 for this. So we've got to do A times 1 minus R to the n, all over 1 minus R. So we'll have 460 times by 1 minus 0.98 to the 24, all over 1 minus 0.98. Which gives us £8,837 and 5 pence. Right, part D. How much would Mary's first payment need to be? So we don't know what A is now. If she wishes to pay 2% less each month, so she's carrying on with her R being 0.98, but to pay the same in total as Jim. So in other words, S24 has to equal 9,240. So if we think about our formula for S24 again, so it's going to be A times by 1 minus R to the 24, all over 1 minus R. So we know now this has to equal 9,240. A is 406. Oh, sorry, A we don't know, so we leave that there. This is going to be 1 minus 0.98 to the 24, all over 1 minus 0.98 on the bottom, which is 0.02. So all we need to do now is solve this equation. So I can do 9,240 times by 0.02, which is 184.8. And I'm going to divide that by 1 minus 0.98 to the 24 in one calculation. So that gives me £480.97. Right, so 2 marks for that one, getting 390. Another 2 marks for getting his total. Another 2 marks, that was for Mary's something payment. And then you needed to get all 4 of these values where you were comparing them. For C, was that what we got? That sounds like what we got. But again, subbing into that formula. And for part D, similar to what we did there, so one for setting up that equation and another one for solving it to get that. Right, last question, question 13. We've got a greenhouse built against a wall. The greenhouse is a prism of length 5.5 metres. The curve AC is an arc of the circle with centre B and radius 2.1. The sector angle ABC is 1.8 radians and AB is a straight line. The curved surface of the greenhouse is covered in polythene. Okay, very interesting. Find the length of the arc AC. Well, we can see here this is just simple arc length. So the formula for that in radians is r theta. So in other words, the radius, which here is 2.1, times by the angle, which is 1.8. So 2.1 times 1.8 is 3.78. So we know this length here is 3.78 meters. Calculate the length BD. Right. So I'm going to draw this triangle CBD a bit bigger. So they want this length BD, let's call it X. So we know this is 2.1, and we also know this angle here is pi minus 1.8, because there's 180 degrees or pi radians in a straight line, so this must be pi minus that 1.8. So we can just do basic trig to work out this length BD. So by basic trig I mean SOHCAHTOA. So we've got the hypotenuse, we've also got the adjacent, so we can say that, if I give myself a bit more space, cos of pi minus 1.8 has to equal x over 2.1, in other words adjacent over hypotenuse. So all we have to do is make sure our calculator is in radians, and then do 2.1 times cos of 2.1 times cos of pi minus 1.8, which is 0.477 blah blah blah. So I'm going to say 0.477 meters to three significant figures. So that's our answer for part 2. Calculate. Oh, missed a bit of part 1. Calculate that, so we're getting a bit enthusiastic. Hence, find the area of polythene required for the covered surface of the greenhouse. Right. So if we think about this sheet of polythene, it's going to be like a rectangle. We know this is 3.78 meters. So this rectangle is going to be 3.78 times 5.5. So it would have an area of 20.79 meters squared. Right. Final question is, so let's just annotate that as 0.477. So calculate the volume of the greenhouse. So we're going to have to work out the area of this and then times that by 5.5. So first of all, the area of this sector part, we can use a half r squared theta. So a half times 2.1 squared times 1.8, which gives me 3.969 as an exact number. And then to work out the area of this triangle, so given that we know this angle, so we can't use half base times height, so we don't know the height. So you could find the height and use that, but because we know this is 0.477, I'm just going to double check that's right, so I've forgotten it. We can do half AB sine C, because we know two sides and the angle between them. So we can do a half times 2.1 times 0.477 times sine of pi minus 1.8. So 0.5 times 2.1, so 0.477 times sine of pi minus 1.8 gives us 0.48778. 0.4878. Right, so in total, the area of this is going to be 3.969 plus 0.4878. So that's, on my calculator, 4.456, there or thereabouts. And then we just have to times it by 5.5 to give the volume. Because remember, this is like a prism. So I get to three significant figures, so 24.5 meters cubed. Okay. So you get 2 marks finding the sector area, 3.969, another mark for getting the triangle area, anything from 0.487 to 0.491, and then final answer of 24.5. And in fact, you're allowed any answer which rounds to 24.5. Okay, good, that's the end of the paper. So I hope you found that useful.